So then why can't 5 plus 4x equal 9x? Because we have a 5 and a 4 and an x. Can anyone tell me why we can't do this?
Oh.
Yes.
Is it because the 4 and the x aren't on the same side?
Yes, because the x is connected to the 4. There's no x connected to the 5, so that's just a value. This is, what's another word for a number in front of a variable? A coefficient. Good. So we can't add a coefficient to a value. So then going back here. So for 63 part A, what should you have?
11. I got 11.
Where did you get? Oh, not for this.
Oh.
Sorry. Not for that. For your question on 63 part A, what should you have? Can anyone give me an example from their paper? And we can see if it's right.
For the answer?
Yes, for the answer.
I got 9x.
You got 9x. And then how's another way that you could write 9x?
X equals 9.
X equals 9. Not sure about that one. So we have 9x and what else? I see a lot of you have it on your paper. You just need to say it. Yes, Joey.
X times 9.
X times 9? Yes, but still looking at the picture, how did you draw that? I see it on that whiteboard. Do you want to tell me? What? Mm-hmm.
5 plus 4.
Right, 5 plus 4 in the parentheses of x. So instead of just having 9x, we can break it apart into two sections. 5 plus 4 multiplied by x. That whole quantity is multiplied by x. So now erase that and show me what you got for 31b. Does anyone want to come up here and write their answer on the board? Logan? You can use any color you want. Other than that. Yeah. And you can use a different Good. Good. Does anyone have anything different from this? Or does this look about the same? So I have a question for you. Are these two equal? Are they equal? Let me see. Thumbs up if you think they're equal, thumbs down if you say no, or thumb in the middle if you are really not sure. Sure. let's use some numbers to plug in with this. So we had the first one as, so what are we plugging in when we plug in a number? Are we plugging in the 1.5, the x, 7, or the 1.5? When substituting in a number, what do we get rid of? X. So if we get rid of x and write, let's say, 2, then we're really multiplying by 2, correct? So can somebody grab their calculator and tell me what that equals? .5. So it equals 13.5. Now if we go down here, we have to do the same exact thing to this side of the equation. So we substitute in 2. So if you want to do that as well. 10?
13.5.
15.5. Yes. So you first do the 7 plus 2, which is 9. And then 9 multiplied by 1.5 is what? 30? 13.5. 13.5. So we can see that they are in fact equal. So now going back, how can we tell just from these two equations that they're equal without plugging in numbers? Does anyone have any idea of how we could use it? Well, what this parentheses actually means is that the 1.5 is being multiplied by both the x and the 7. So if we break it apart, you still have them added together. Still have them added together, but you can rewrite it so that it's the 1.5 multiplied by x right here, and the 1.5 multiplied by 7 over here. And you still have the addition just like down in the original equation. Does that make sense? So the distributive property says that if you have certain numbers in parentheses multiplied by one number, then that one number must be multiplied throughout the whole entire parentheses. What is 10? Is it a coefficient? Is it a variable? Is it a value? Yes?
Well, on the graph of the example, like if you're deciding what something you like there's some point, so you're at like upfront cost or there's
Okay.
where you start at.
So it would be like an upfront cost, which we will call, since we have a value here, we're going to call that the upfront cost. Now what's different between these? Is there anything different between these two equations? Yes?
The first one has addition and the second one has subtraction.
First one has addition, the second has subtraction. Are we going to be able to solve these equations the same way, or are we going to have to take a little bit different steps to get to solving for x? Different steps, right. So we will how would we start with solving this equation? 2x equals 10, or 2x plus 10 equals 16. Yes, Joey.
Subtract 10 from 10 and 10 from 16.
Okay, so subtract 10 from each side. Now what do we get once we subtract 10 from each side?
2x equals 6.
Good. 2x equals 6. Because 2x plus 10 minus 10 gets rid of the 10. And 16 minus 10 is 6. So now what can we do? Yes?
Divide each side by 2.
Divide each side by 2. Why can't we divide each side by 2x?
Because both sides don't have x's on them.
Both sides don't have x's on them. So there's no need to divide by 2x, only by 2, to separate these two x's apart. Like if you remember in the coins and pouches problems, you just separated the two pouches and separated the two pairs of coins. So then we would have what? Can someone tell me?
X equals 3.
X equals 3. Now if we go over here, how would we solve that equation using roughly the same steps? Someone else besides Logan. Besides Joey too. That back table's been pretty talkative today. So what could we do in this equation to get to having a single x? Yes?
Subtract 10 from both sides.
Subtract 10 from each side. So then what would we get if we subtracted 10 from each side?
2x equals 6.
2x equals 6? Well, let's work down. 2x just stays there. But then we have a minus 10, or a negative 10, minus 10. So what is negative 10 minus 10?
Negative 20.
Yes, it is negative 20, so we'd still have a negative 20. So are we really getting anywhere if we subtract 10? No. We're just getting further away from our goal. But what can we change in order to get rid of that 10? Yes? Add 10 instead of subtract 10. So if we add 10, the negative 10 and the positive 10, they cancel each other out, right? They add up to 0. So then that would equal, what would 16 plus 10 equal? 26. Now what would I have to do? Yes? Divide by 2. Each side by 2. Good. Then what would we end up with? Yes?
X equals 13.
X equals 13. Is x equals 3 and x equals 13 the same thing?
No.
No. Correct. So your initial thought that these two are different because of the plus and minus signs, it really does make a difference, doesn't it?